Hello everyone, welcome to Cloud Operator Days Tokyo 2023. I am Nisha Brahmankar. I work at Line Corporation Tokyo, and this talk is with my colleague Bharadwaj, who also works at Line Corporation. Apart from working at Line Corporation, another thing that is common between us is that we both started our journey as new grads. So last year we joined Line as new grads, and it is 1.5 years into our cloud career. So this talk is our journey, really a beginner's journey of operating production level private cloud using OpenStack. So yeah, let me give you a quick overview of how the talk would go about. So first we will start with the beginner's view of OpenStack, followed by some details about the Lines Cloud and our very first task, followed by the work we did and some challenges that we faced as beginners, and also some details on the current project that we are working on. So let's get started. What is cloud computing? So cloud computing is running and managing workload within clouds. And what is clouds? Clouds are environments that abstract, pull, and share resources across the internet. So all of us are aware of the life before and after cloud and how and why cloud is important. So let's move on to the layers of cloud computing. So there are 3 layers, as you can see in this pyramid: IaaS, PaaS, and SaaS. I need to mention that OpenStack lies on the very bottom layer of this pyramid, that is IaaS layer. Also, I love this analogy that we can think of the layers of cloud computing as leased car, taxi, and bus. It's fun to think it like that. Next is, what is OpenStack? So OpenStack is a tool to create and manage smaller large clouds, public or private clouds. Why OpenStack and the scale of OpenStack? So you can see that OpenStack is widely used across all the broad spectrums of these days, and it's very reliable, economical, and many more pros. So yeah, OpenStack is wonderful. These are some of the important OpenStack components, which we also work at Line. So next is Verda. So what is Verda? So Verda is the name of Line's private cloud. And here are some of the services that Verda provides: VM or bare metal, that is physical machines, app engines, containers, shared file system, load balancers, DNS, etc., etc. So this is the Verda services. To give you a rough overview of the scale of Verda, so these are the number of physical servers, bare metal servers, hypervisors, and virtual machines at Verda. This is the number as of January 2023. I think that pretty much explains the large scale of Verda. This explains resource provisioning at Verda. So the end users of Verda are Line developers, and we lie on the top right corner, the infra team. So we manage Verda. Yeah. So let's get to the more interesting part, our very first task, playing with personal Verda. So when we started as beginners, we wanted a playground to like play around with OpenStack and to dive deeper into how OpenStack works. So for that, there are multiple options, for example, DevStack or as well. But all of these options come with their own pros and cons. So what we did at Line at the start was we build our own personal Verda. So what is personal Verda? So we use Ansible to create personal OpenStack clusters. So you can look at this diagram. So we have our dev cluster hypervisors, which on top of which we have dev cluster VMs. Now what we do is we configure this dev cluster VMs to we configure them as personal cluster hypervisors, and then on top of that we will have our personal cluster VMs. So it's kind of like on dev cluster environment we have a personal cluster environment. Basically it's nice to think like it's a cluster on top of a cluster. So that is how personal Verda is built. And apart from using personal Verda as beginners playground, we even use it now these days, as test environment before we move on to the actual stage and production environments. Let me throw some light on the work that we have done so far. So first of all, let me talk about some features in Nova. So Nova is one of the critical component in OpenStack. And these are the two features. So let me start with the first one. It's the user script feature for PM. PM is a physical machine, that is Line's original Nova bare metal driver. So this feature provides a user script which will be run on VM on the boot up. So basically, if you can see in the command number A, in the create command, we can provide this user data user script. You can provide this user script and it will run on the physical machine boot up. So this feature actually exists for the virtual machines in OpenStack. So we provided the same feature for physical machines as well, which is the Line's original November metal driver. Second is scheduling VM on specified aggregate. So as you can see in command number B, so you can specify aggregate number and the VM would be scheduled on that specified aggregate. So how is this achieved? It is achieved by adding a new Nova scheduling filter. And how it works is basically matching the key value pair, and that is how the hosts are filtered. Yeah, so these are the two Nova features. Next, I will hand it over to Bharadwaj, who will explain more details further. So thank you.
Thank you, Nisha. Let me carry on from here. Continuing on the R work aspect, another work that we have done in the company in the recent 1 year is the neutron agent containerization. So as you all know, many of the services in OpenStack, they run on the same hypervisor. So sometimes it can cause clashes among the different packages that they use. So usually it doesn't happen, but it could happen if you are like changing or trying to upgrade some of the packages on the hypervisors. So to avoid such cases, we started with containerizing the neutron agents for a starter, and we managed to containerize our neutron agent that we call as L2 isolate agent using Podman. And this has enabled us to use the different package versions independently now on the same hypervisors. So moving on. Next, I would like to discuss more challenges as beginners that we have faced in the last 1 year. So starting with the most basic of all, but still yet the most difficult one is the keystone authentication part. So since we have many different environments, including the test environments or the production environments, so each of them will have its own OpenRC files now, and each time we have to source each of the OpenRC files, and this can cause for a beginner it can be pretty difficult, and the user can get overwhelmed. The admin can get overwhelmed by it. So, so there are few tips. Of course, we cannot avoid this issue completely. We have to source the RC files, right? But there are some tricks and solutions that can make it faster and make it better, the whole entire process. For example, we can use a simple basic shell, modifications, like adding the once we source a particular OpenRC file, we can use some kind of meaningful name, and that can become part of the username. For example, in this, you can see as soon as I source the stage for prod OpenRC admin, I get I have added a staging keyword in my username. So there is a very simple script that everybody can use. And second would be using autocomplete and auto suggestions, which can be enabled by adding these to the bash RC files. And lastly, there are other third-party tools like Rally, for example, that provide a very friendly interface for fast context switching. So those can also be used. Moving on, another challenge was how we deploy our changes. Since we have a large number of hypervisors, like more than 10K, it usually takes hours to deploy to all the compute nodes, even after all the tricks that we're using. For example, for some of the tasks or like the playbooks in Ansible, we have divided it into smaller handlers, just so that like if we deploy the neutron agent restart aspect, we don't have to run the entire the neutron agent deploy playbook separately. We can only run the restart agent .yml task, right? So that will only do the restart task. So such division of labor can be done to make it faster. Also, the hypervisors are divided into host subgroups in the Ansible host file so that when we deploy, we can deploy it in parallel. Yeah, so as in when we deploy changes and then we move on to test our changes, we always face uh, issues or outages. So some of them are given here, and like how as a beginner, how was I able to learn some of the things, and also what were the steps that I learned. So, for example, one such error was like once when we do the OS server show, OpenStack server show with the server ID, sometimes it could give the error like fail to allocate network, right? So, in such cases, we know it's on the Neutron side. So, we can get the tap interface ID, the interface of the VM of the server ID that is giving the issue. We can use the following commands like Neutron port list with the device ID you provide. The first 10 characters of the above output will be the port ID. For example, tap XXX something. Now check the tap device on the compute node. Go log into the compute node and do write the command IP address and grab that tap device. You will get an ID. Now the next step would be check if the messaging driver that was used, like the RabbitMQ, or if that is working or not, like it is able to provide the communication between the Neutron server and Nova. If that is also okay, then check if the tap interface worked or was created on the compute node. For that, you can do the following checks, like check if the Neutron agent is running or not using the systemctl status. Also check if too many interfaces already present. Some hardwares impose upper constraint. Check if the IP route, IP tables, and IP set packages are installed, like using yum list and grep for the package. Also, the very good place to check for errors would be the logs of all any services in general. You can search for the error keyword. After this, the next step would be check if the IP is assigned. For example, if this is the case that IP is assigned, but not it is not pingable. So in these kind of scenarios, check status of the DHCP server, like the DNS mask. Sometimes it could be not running, so that could be the issue. Check if the DNS mask or DHCP present is running, and it is assigning the IP. So you can use TCP dump tool to check the communication between TCP dump and the VM. Also check if there is any security group rules in place, so which could allow inbound traffic on the compute node. If it is not present, usually then it will not allow the incoming traffic to the VM. So that could cause the ping failure. So here I mentioned some of the tools which are usually useful for such kind of outages. You can check these. Yeah, so the current project that is ongoing in the company from our side is the upgrade of the OpenStack in the entire cloud from the older version to the Z version. So this is the older version, and this is the new Z version that changes that we plan to bring. So, to achieve such a massive scale, in such a massive scale, such kind of a change, how did we proceed about it? So, firstly, we set up a very testing environment, which we call as a test environment. So, in that test environment, we used all the all the services of the with the Z repository. So, be it the Nova or the Neutron, everything is in the with the Z repository, and we install and set up the end-to-end all the services in the with the Z version. So this is a more in detail diagram or the flow of the entire process. So we started with the Z upstream code with custom patches. So the custom patches are our own patches in our company that we add to make our to make few offerings that we do in our cloud. So those are also added with the Z upstream code. Now we check if all the unit tests and functional tests are still passing. If not, then we fix the changes accordingly. If yes, then we download like the entire repos on and install the services on the actual nodes, be it the control nodes or the compute nodes. And then we also had to modify some of the configuration files because it has been some time from the previous one to the Z version. So there were some changes in each of the cons. Accordingly, we have made them. And then we ensure the end-to-end API correction using the CLI. So we create a server or we create a port and we check if end-to-end everything is working or not. Yeah, so in the above project, there were also some challenges. There were many challenges, in fact, but here I've listed only few of them. So like, for example, the config parameters that I mentioned, many of them were deprecated in the Z version. So we had to, find either the similar ones or entirely remove it or even new configs in the same place, like rabbit host or other RPC backend, allow overlapping IPs. So these were deprecated in Z. Also, then in on the controller node or even in the compute node, there were some networking packages that were required, like the DNS mask utils, IP and contracts. So these were installed accordingly during the testing phase. And also, we found that some of the Linux version in that we were using was incompatible with the type of network that we are trying to offer. So one such a kernel parameter, the NF hooks LW tunnel, was introduced in Linux version more than 5.15. So we had to upgrade it to the latest version so that we can use the parameter. Also, the NF contract module is needed on the compute nodes to enable networking tunnel. So this we also found during the testing phase. Yeah. So I think I'm done on my aspect, on my part, and I think that's all. So thank you everybody for listening to us. It's been a pleasure. Thanks.